So now let's suppose you want to find the DeMorgan equivalent of this expression here. And so this could be equal to something, or maybe we took it out of a bigger expression. It's fine if you want to take certain parts out and simplify just parts. That's totally a reasonable thing to do. As long as they're equivalent, you can always put it right back in. So the first thing we're going to do is kind of do the DeMorgan's complement. So we're going to go through, we're going to kind of assume, well, so just as a reminder, what we're really doing is putting parentheses around this and priming it, and then we're priming it again, because we know from one of our theorems that if you prime something twice, it's just the same thing. So first, let's distribute this prime into all the symbols, and so that's computing the DeMorgan's complement. So we're going to have an x, and we're going to have a y, and a z, and a y. And so here we've got x prime, so that means we've got normal x. We've got y prime, so here we've got unprimed y. We've got z that's not primed, so that means this guy has to get primed, and y stays unprimed. And then we change our ands to ors, and our ors to ands. And remember, we've got to change our precedence, or maintain our precedence order. And so these ands, this and here, and this and here should happen first. And so we're going to put parentheses around it. Maybe as just a rule of thumb, whenever you're changing an and to an or, just know that that term is going to have parentheses around it, so we make sure we do that first. And that's applied this, and so our last step here for the DeMorgan equivalent is to have our second prime, so that makes it equivalent. Because remember, if we just apply the complement, that's the exact opposite of what we need. We're trying to get an equivalent in this case, and so that means we need to prime it again. Now you could look at this and say, hey, why don't we distribute this into here? Why don't we distribute that so we don't have this prime on the end? Well, ask yourself, or maybe even better yet, try and see what would happen if you did that. And the result would be you would end up with this original statement here. So you would basically undo all the work that you did. So we want to keep this here so it's still equivalent, but now we've got our ors changed to ands and ands changed to ors, and we've got some stuff flipped around. So this is our final form.